I'm teaching AS Level Further Maths under the EdXL specification. I'm on the statistics module. Today I'm doing chapter 4, which is hypothesis testing. So I'm going to start off with mean of a Poisson distribution. So to carry out a hypothesis test for the mean of a Poisson distribution, you form two hypotheses. First is the null hypothesis, H0, where lambda is equal to m, and that is the value of the mean you assume to be true. And then there's the alternative hypothesis, H1, which tells you about the value of the mean if your assumption is wrong. So now I'm going to do an example where accidents used to occur at the rate of 6 per month. In the month after traffic lights were installed, 1 accident occurred. This is just a paraphrasing of the full question to show you how it works. Okay, so first you need to let x equal to the number of accidents in a month, and you write out your two hypotheses. So we have H0 where lambda is equal to 6, and H1 where lambda is less than 6 because we're testing whether the accidents have been reduced. And we're testing a 5% significance level. So first we assume H0, so that x has a Poisson distribution where lambda is 6, and because there was 1 accident in the month after the traffic lights were installed, we have to basically test whether that is just a random occurrence or whether it's proving something has changed. So it's the probability of that happening, and how probable is it that it's just a random occurrence happening. So we do the probability that x is less than or equal to 1, and that is 0.0174. And because we're testing at 5% significance level, you know that 5% is 0.05, and we know that 0.0174 is less than 0.05. And so therefore, the 3 dots are the therefore sign. I just prefer to shorten it, but whatever. Therefore, there is sufficient evidence to reject H0 and conclude that the lights have reduced the number of accidents. Okay, now I'm going to move on to finding critical regions. So the critical region is the range of values of the test statistic that will lead you to rejecting H0. The value or values on the boundary of the region are called critical values. So for a one-tailed test, it has the alternative hypothesis H1, where theta is less than m, or H1 where theta is greater than m, and there is a single part of the critical region and 1 critical value. Whereas for a two-tailed test, it has the alternative hypothesis H1, where theta does not equal to m, because there are 2 parts of the critical region and therefore 2 critical values. Okay, so now I'm going to do an example of this to show you how critical regions work. So here's a question, and the mean number of goals over several years is 0.7 goals per game, and we're testing to see whether the rate of goals increases after she transfers teams. We're monitoring the number of goals that she scores in her first 10 games, and we're assuming a Poisson distribution. So we write our two hypotheses first, so H0 where lambda is equal to 7, and H1 where lambda is greater than 7, and we're testing at a 5% significance level. So first we assume H0, so that x has a Poisson distribution where lambda is 7, and we just need to do the probability that x is greater than or equal to the critical value is less than 0.05, because we're testing at the 5% significance level. So for the probability that x is greater than or equal to 12 is 0.0533, but the probability that x is greater than or equal to 13 equal to 0.0270. So basically what you have to do is you just have to input numbers until it passes the 5% significance level. So until it's less than 0.05, that is in your critical region. So any number before that is not in your critical region, and the second it passes 0.05, or what goes below it, it is in your critical region. So then you have to write the probability of x is greater than or equal to 12 is 0.05, but the probability of x is greater than or equal to 13 is less than 0.05. So the critical value is 13, and hence the critical region is x is greater than or equal to 13. If you're doing this in a real question, you then get asked something like she's done this many goals, and then you have to write a conclusion, whether it's in H0 or H1, and you always have to use words from the question when you write a conclusion like that. So for example, in the first example we did, when writing a conclusion you always have to include words from the question. So it'd be yes or no, the number of goals she scored has or has not increased after she transfers teams. And that's all you have to know for hypothesis testing for Poisson distributions. Everything else in this chapter is A-level work. And I'm only doing AS level content right now. So thanks for watching. Bye!